now these words, the this, is, and having, they are called stop words in English language. So there are several words like that which are considered the stop words. So we have the library for that. There are several words, but irony is that there is one word is included which is like where it is it's here. Okay, where here. So not is also included in it. So basically the stop words, yes, they should be deleted from the review, or I can say not being considered for conversion while the process is being implemented. So you are thinking of this NLTK.com, what is that package, or what is this all about? So NLTK is basically the natural language toolkit. So there are several packages and the libraries in NLTK for text processing, manipulating, and several things. Okay, so we will talk later about all these libraries, and we will implement all this in our the building the machine learning models related to NL, okay, natural language processing. So okay, and so there we had gone through all the process, how the text is being converted to vector. Now there are several things are being coming in between. That is, there is some like pre-processing needed for the text, because if we consider the whole and soul the text which we had got from the source, it has very absurd things which are not to be included in the formulation while conversion. Okay, so otherwise there are several words which will form the whole. The set is literally big. The bag of words, vector of bag of words, is literally having lots of words which are not really of use. So text pre-processing needed. So there are several methods, or I can say the sequence in which we go through, so that we can perform the text pre-processing very comfortably. So first is the removal of stop words. We had already discussed this, that what are the stop words and how we implement. We will talk or implement this in our next videos. Okay, so how these stop words, but we know that stop words should be removed, but there is one thing that not is also considered. So what it makes the difference. So we must be very clear about how and when to implement this individual stages. Okay, so if we see these two reviews, the not word literally make the word the sentences meaning completely opposite to each other. That here it is saying like car is cool, and here it is saying car is not cool. That means they are saying the totally opposite thing. So while not considering these stop words, while performing each stages, we must be very careful about all these techniques or methods. Okay, while text pre-processing. So, and coming on to the next, that to make all our words of lowercase. Yes, it's obvious that we seen from the review that so computer don't know that this car and this car is same or different. He simply take it as a unique words. So it will make a more larger set of words. So it's not of use. So that's why for while implementing text pre-processing, all the reviews text, all the documents, complete documents, all the corpus text should be in the lower case. Okay, and coming on to the next thing, that is we call it stemming. It's really important, and you had also noticed this, that there are several words having the same they are the same words but are written differently, like cheapest and the cheap. So talking about, they both have the same base word, that is cheap. And similarly, affordability and affordable, if we took out these words, stop words, this is, so, and but, what is being left here? Car, cool, cheapest. We are still we are connecting the dots, right? That car, cool, and cheapest. Car, not cool, affordable. Yes, so the link is still there. So stop words are being removed, but still there are things like the words are the words are being used repeatedly. So they might the computer would always take those two different those words as different, but in stemming what we do, we basically uh, convert replaces these different words like cheapest and cheap to their base word, or I can say the stem form, that is cheap. What is the base word for affordable and affordability? The affordable. It's the same thing. So this is the method, and there is two algorithms used for this, and they we are not going to discuss about how the algorithm is being designed, because it's the work of those who are literally very diving deep into the algorithm stuff, designing algorithm. So we only took the algorithm and implement in our model. Okay, so there are two algorithms, Potter stemmer and snowball stemmer. So Potter is little older one algorithm, and the snowball stemmer is far more powerful, and we will implement and we will see how it works. Okay, and other thing is lemmatization. So lemmatization is basically the algorithm is basically designed to see whether the words are being considered while conversion, or I can say text while text pre-processing these words to be considered or not. Otherwise what will happen, like there is one example that this car is so cool and best in New York, but if computers will see this, he will see this car is so cool, so he will delete those words which we consider stop words, but there are words like New York. So this New York is a location, it's not a word. The thinking so basically this what this algorithm does, this algorithm is designed to see with broad view, like what is it is being talking about. So he would consider this as an word, not as an stop word or any useless any absurd word hanging in between the sentences. So this lemmatization does. So we also going to implement the algorithm, and there is one last problem you would definitely gone through, and you are still seeing that there are several similar words like cheapest and affordable. Cheap, affordability. So we had already discussed about the affordable and cheapest, so their base words is cheap and affordable, but there is something else, that affordable and cheap are basically the same thing. If you say one human that what's the difference between the R1 and R4, so there are little difference, but there is something else that human can distinguish, that cheapest and affordable, cheap and affordable, they both are the same thing. But computer, as per the computer algorithm, he really take it as a different words, because he can't make a distinction between those two words. There is distinction as per the computer, but human can see that they both have the same meaning. So as per our technique which we are going for, text and vector conversion, text to vector conversion, so there is one drawback for this technique, bag of words technique. So he would not go for considering these similar words and converting those different meaning, having the same meaning but different words to a one word. So we will talk this about this last thing, that is the drawback of this bag of words technique. So this would be we would consider this in the word to vector technique. We had already discussed this, right? There is many techniques. So this, the word to vector, we will going to see how this last one would be considered and implemented. So this is all about, we had done today the text pre-processing, how it is being done, and second thing, how the conversion of text to vector is being performed. In continuation, if we see that if we proceed with removal of stop words with the above example, so let's say we had already discussed about lemmatization, right? So what is lemmatization? In it, we basically, what we do, we see each word by breaking the sentence and also considering the loss of valuable information, that whether the information is lost or not, it is important. So lemmatization is that by using the algorithm of lemmatization that we will go with it. Okay, so about the algorithm part and how it is being implemented, and starting with this, let's take one example that it is written over here, that there is one review textual data that we have. This car is very cool and affordable, and R2 is this car is not cool and is affordable. So on application of removal of stop words, let's see what are the stop words over here. So these are, okay, so we have different words. So where it is, on seeing this, the end is also an stop word in English. Okay, and we have different words like this. Okay, this is very not, these all are stop words. Let me check this. Okay, so not, we had already seen that not is also an stop word. Let me confirm this very is also an stop word or not. Okay, so yes, see, very is also an stop word which is giving an wrong information to computer. So if we apply this, it really literally make our conclusion wrong. So on seeing this, what we conclude, what computer conclude. So on removing this all stop words, basically what we are doing, we are proceeding with the text pre-processing sentences, or I can say methods. Okay, so these are removal of stop words. So this is the first step, or I can say we can go with it on textual pre-processing. So we are removing the stop words. So on concluding, after the removal of stop words, the vector of each sentence of or each textual review is coming out to be same. This is the conclusion, that after removal of all these stop words, the R1 and R2 reviews are similar. That means because there is not over here and computer is concluding that these two reviews are same, which is wrong. So what was the problem? Problem is here it is creating, like the computer is concluding now that we are not coming out with sequential information. The sequential information is lost by removing all these stop words. So how to resolve this? So this is resolved using the unigrams, bigrams and n-grams. So now what is unigram and bigram? So with this we can say here, like unigrams we had already discussed. Basically our d-dimensional vector, when we say that we are performing lemmatization, so in that we are breaking sentences into words, right? So here in unigrams, each word is considered a dimension. So like we have different words from the review sentence, okay, review document. So this car is, they are considered, okay, this is considered each dimension. This is one dimension, car is also one dimension, school is also one dimension. Similarly, in bigrams, we take pairs of consecutive words as a dimension. So that will reduce the reduce the information loss. Okay, sequential information loss. So So how the d-dimensional vector is being formed using the bigram, or yes. So here we have the example. This car, this is in sequence, consecutive words. Okay, so this car is considered to be one dimension, and then car is another dimension, and in the same way, very cool and not cool, these are considered to be the two dimensions which are totally different. So that means computer will conclude that these two reviews are different. Okay, so with the help of this bigrams, and also we have the different n-grams means we can proceed with by, try, or many. Okay, so they are called n-grams. Now why we are all considering all these unigrams, bigrams? What is the reason? We had already discussed. So because in bag of words, it completely discards the sequential information, right? We had gone through this. So like how it is ignoring the sequential information. So in bag of words we are considering the unigram method, or I can say the d-dimensional vector is considering each word as one dimension, right? So in that the sequential information is lost. So on using the different n-grams, we will retain the sequential information, so which is really helpful, and it is also help in applying the removal of stop words. This text pre-processing is helpful then. Otherwise it will totally make the conclusion that we had already gone through, that is the two reviews are similar, which is not. Okay, and another thing, so what is the price for that we have to pay for this is basically the increasing dimensionality. On increasing the different d-dimensional vector, on increasing the dimensionality of d-dimensional vector, the size of d-dimensional vector drastically increases. Yes, it's a problem, and we will talk about it in later sessions. Okay,